Hello everybody, and thank you to be here in this session. I'm Juan Carlos González. I'm Head of Innovation in the Instituto of Biomecánica in the area of clothing and footwear. And I'm going to continue in some way the presentation of my colleague Sandra, but focusing on applications in the apparel industry and also in the new technologies to scan the body in 3D with the smartphone. The content of my presentation, I will start with the applications of body measurements and 3D data in the apparel industry, which are the limitations of the current approaches for collecting body data, for having access to this body data, and which are the requirements that an optimal solution should have in order to overcome these limitations. And I will explain which is the solution, the technology that we have developed, and what's next, which are the next steps in the development of this technology. Going now to the applications of body data in the apparel industry, as my colleague Sandra has explained very well, we have some applications in which we need the anthropometrical information of a population, of a target population. For example, if we want to design new garment for a specific population, for men from 20 to 30 years, for example, or when we want to create virtual collections. And we also need the individual information of a customer for other applications like the sizing recommendation or the made-to-measure or bespoke clothing. Going now a bit more into detail in these applications, for example, for the design of a new collection or for the adaptation of a collection to a target population, companies are more and more aware of the importance of having products that really fit this specific target group. For example, in the last year, we have seen that many companies has developed collections for big sizes, for example, and they are working a lot in improving the fitting of this clothing. Companies usually in the markets where they work, they have optimized this pattern design and also the sizing systems. But when they face new markets, for example, and different countries or different populations, to know the dimensions and the shape of the body of this population allows to have better products and to go quicker to the market. Also, we have seen that one of the biggest trends in the apparel industry today is the digital transformation. At the end is the digitization of all the process of the company that improves, makes better, faster, and cheaper processes. This is very relevant in the design process. In this case, it is probably one of the parts of the company is more complex to digitize, because we have, from one side, we have to digitize the user, the customer, and from the other side, the clothing and how the clothing looks like in a digital environment. In this case, companies start from 3D avatars, from avatars that they select, for example, because this is the model, the average body for the company for a specific collection and a specific size. And there are also available 3D mannequins that can be implemented within the software design programs in order to design, and also visualize how the collection looks like internally for the company and even for the customers. And there we need also information of the 3D avatar in order to fit the clothing perfectly in a virtual environment. Going now to applications of individual data, it is another of the trends that has been boosted by the pandemic situation is the e-commerce. Every year, companies has a higher percentage of sales on internet, and in order to reduce returns that are different studies show that are quite important in online sales of clothing, but also to generate trust and confidence on the customers. Many companies have implemented sizing and fitting systems or even virtual try-on technologies, so the customer can see how the clothing fits, and they can select the best size for them. The input for these systems is also the anthropometrical data of the user, very important. And another of the applications that is increasing in trends is the made-to-measure or the bespoke clothing, where also the most important, or one of the most important input data is body measurements. This industry is mainly followed by traditional tailors and follow traditional methods, that's measuring by hand the user. But as this business is growing and the number of companies is growing, they are starting to use 3D scanners in order to make quicker acquisition of data. And also there are appearing online businesses in which they provide customized clothing from internet, and it is also important to have as an input the information of the users. And yeah, we have seen that there are many applications, important applications in these last years of anthropometry information in the apparel industry. But how we can collect this anthropometrical information for our customers, and which are the limitations of the current approaches that any company can follow. When we address a target population, a specific population, the main source historically has been the development of anthropometrical databases for country surveys. You can see in the map in the slide that this is a collection of the last surveys that have been done around the world, and there are some of them are ongoing, like the North America survey performed by Human Solution, and this information has been very important for the clothing industry during the last years, but there are some limitations for accessing to this data. First, make these studies is really expensive. You have to take a scanner around a country or a region and measure thousands of people. The logistic cost and the cost of the studies is really, really high. Another limitation that Sandra has also speak about that is that this information is static. You make a study 1 year, but if the population evolves, then you have to repeat the study again with additional cost. And two limitations that are very important and that are limitations that are being faced by the BodyPass project is that this information is, as you can see in the map, is fragmented. It's difficult to compare one study with another because what they can be made with different scanners, different processors, different poses, and they are many times not accessible because it has been developed by a consortium of companies and they want to maintain this information secret. Or also, as it has been explained this morning, because it was not well done, all the security and protection of data, and then you cannot share this information if this is not anonymized. And finally, maybe this is not so important, but it is true that when you use a generic database, although you can make some segmentation of the customers, of the target, at the end these are not the specific clients, customers of a company, and sometimes these anthropometrical studies don't have a good description of the user. So at the end, for example, you don't know if this is people that is making a lot of sport because you are a brand of sport clothing. When we speak about individuals gathering information of individual customers, here we have different sources to gather this information. One of the most interesting is to put a scanner on the point of sale in the retail, This is quite interesting because it's attracting customers to the shop. You can make a very good experience. There are scanners like the one in the photograph that has a very nice design, but we have also some limitations here. First, you have to take the customer to the physical location, and you cannot have many locations because these scanners, although they have decreased in price in the last years, it is still a high inversion for a shop. That makes that this approach is not scalable. You cannot gather a lot of information. You cannot gather, I mean, if you're a big company, you cannot gather a significant percentage of your clients with these techniques. There is another approach for many companies, mainly for the recommendation of sizing, that it's to ask the customer to measure themselves and then apply this information with size guides in order to recommend the size. What we have seen from the research that we have performed at IBB is that these measurements are really inaccurate. We can get more than 7 centimeters for very important measurements like the hip or the waist curves. And if we want more specific measurements, sometimes not so extreme, for example, the length of the leg or the length of the arm, these are measurements difficult to take if you are not an expert. And finally, another of the limitations is that this is very time consuming, and you need to go for a tape measuring that maybe you don't have one at home, and then take the measurements. So many users at the end don't take their own measurements in order to have this data as input for example, the size and recommendation systems. There is another new techniques. In this case, for example, when we used artificial intelligence and the virtual closets of the customer, or for example, the customer order and return history, these techniques really don't give the company information about the anthropometrics of the user, but you can have information related with sizing that can help to select the best size for the user. But these techniques also have great limitations. First, you need very large databases and training periods in order to require to set up the algorithms. And what is more important, for example, some weeks ago, it was a conference in the PI Apparel conference in New York, and Zalando was very clear. There were a presentation of Zalando, and they were very clear. And for example, they have a size advice in their web, and there were many people that didn't use this size advice, and they were aware that many of these customers were new customers or had a very low purchase history with them. So the conclusion that they reach is that a system like that is not viable, because at the end you can left many of your customers without a good size recommendation. Another approach for gathering the individual anthropometrical information of the user are systems based on the estimation of body measurements from basic user data. Usually it's the age, the height, and the weight. And in many cases, the web allows the user to make some adjustments on the avatar. For example, to define which is the shape of your abdomen or your belly or the shape of your hip. What we have seen in our research, and also it was supported by the conference from Zalando, from the chat from Zalando that I explained in the other slide, is that the systems based only on age, weight, and height don't provide a 3D avatar in which the customer can be recognized. In most of the cases, if you have a shape that is close to the average, then well, you can recognize yourself on the 3D because it could be quite accurate. But if you are not in this average shape, then it's difficult that you can recognize yourself on this. And when we try to adjust these 3D avatars with some auto adjustment, as I said, for the shape of the abdomen or the hip, this has a negative impact in the final avatar. And for example, Zalando said that this produces an error of more than 2 sizes up and down from the optimal size, because at the end it seems that we don't recognize ourselves in the shapes. We don't have a clear idea of how our shape is. So seeing these limitations, we have defined some requirements of an optimal solution in order to gather information of the user in these different applications. And the requirements are, the basic requirements are that it should be accessible to all customers, accurate and easy to use, low cost, not to have a high investment. It is important to have a good 3D visualization so the user can recognize themselves and generate trust. And you need to provide the body measurements. It should be scalable in order to gather as much information of your consumers as at a low cost and with the less complexity in logistics and investment, and to be that dynamic. So if my target is evolving, then I have to follow this evolution and have information on how my customers are changing. And yeah, seeing these requirements, the better approach that we have seen and many other companies is to use the mobile phone. Mobile devices are really very extended. Almost 75% of the global population is connected by a mobile device or a mobile phone. And we have a camera, we have sensors, we have a computer, and we have connection to internet. So with these requirements, some years ago, we started the development of the technology to capture the body in 3D from 2 images, with the objective that we could have this information from any smartphone. We have developed this technology, and we have developed a demonstration application that it's called 3D Avatar Body. It is an Android, and you can download and use it. This application sends the images to our server, to the cloud, where we process the images and return in about 30 seconds the 3D model and a set of more than 100 measurements. I mean, the technology allows that, but the demonstration application that we have only show about 10, is limited and only shows about 10 of these 100 measurements. And finally, we provide a web service that can be integrated through APIs into any application pipeline or business model. But how this technology, how it works, which is the secret to have this technology? Well, we start asking the user, the customer, the age, the weight, and the height, and we generate a guiding outlined on the mobile application, so the user can reach the optimal pose and distance to the mobile phone to take the pictures. We take the pictures, and we also register the gravity sensor and the camera parameters, because that gives an extra of accuracy to the mobile application. And we send this information to the server. There we have 2 processes. From one side, we detect the key points over the photograph, the landmarks of the body, and we generate the segmentation. That is this red line that you can see on the slide. That is the silhouette of the body. And on the other side, with the camera parameters and the gravity sensors, we generate the projection matrix estimation. This sounds very technical, but basically what we want to know is from where the photo has been taken and which is the inclination of the mobile and and the focus distance, so we can approximate the outline, and we can project later that into our model. And finally, we use a mathematical model. We call it data-driven shape of space of shapes, sorry. But basically, it's a parametric mathematical model of the body that we have developed from our own databases in 3D that we have been gathering in the last years. And we modify this mathematical model in order to adapt to the outline, to the silhouette of the body in the frontal and lateral view. And from this 3D model, we can extract the measurements of the body in an automatic way, and we can also add the skeleton, the rigging, to provide movement to the avatar. We have carried on different validation studies about the reliability of the technology. This slide is really nice because it shows how accurate visually our approach or application reproduces the shape of the body. You can recognize yourself in this with this technology, and we have performed also more quantitative works comparing our technology with high resolution laser scanners. You can see also which are the results that are quite good. And we have compared also numerically both types of scanners, and we have reached the conclusion that our technology is as reliable as high-resolution 3D body scanners, and the error is very close to this gold standard for us. In the same sense, we have developed similar technology for scanning the foot for applications very similar to the applications of clothing. There are companies that are using this technology for sizing recommendation, for customization of footwear, insoles or ski boots, or just for gathering information of their clients, so they can have a better idea of which is the size, the foot, and the shape of their customers to develop better fitting shoes. And what's next with this technology? Well, the one of the research that we are conducting is to have a less restrictive input. We have seen that, I mean, our current technology needs that the user is wearing a tight clothing very close to the body, so we can have really the silhouette of the body. But yeah, this is a limitation, and also they have to be in a specific pose. So the idea is that we can work in having this technology working with any clothing or any pose. Even in the future, it probably would be possible to gather to gather different photographs for example, for social networks, in order to have the very accurate 3D model of the individual. And another of the tendencies now on the phones market is introducing depth sensors that can provide a partial 3D view of the image that is capturing, and yeah, that could improve in the future the segmentation, or even to provide better accuracy in the 3D. It is true that these sensors are nowadays introduced only on the high-end mobile phones, and we should follow the trend. If finally it is included in all the smartphones, it could be interesting to add these features to our technology. And that's all. If you have any questions now, I can try to answer it. Thank you.
Okay, thank you, Juan Carlos. We have 2 questions. Okay, how can we test the mobile app to scan the body?
Well, we have this 3D avatar body application. You can download this application from the Android store. This is a demonstration application. It is not a commercial application, but it is quite interesting. You can get about 10 measurements. And if you send us the code that you generate, we can send you the 3D. And we have additional possibilities to make higher tests or bigger tests because we can provide you the APIs and you can develop a first application for your company.
Okay, one more question. How do you make sure that the data is private on the phone and not allow improper access?
Well, we follow the GDPR reglement. So first we ask the user for their consent in order to use this data, and then we use a safe communication with our server. And once we have used the photograph in order to select the silhouette, then we can delete this information.
Okay, and the last question is, do the customers give the actual height or weight? The weight is probably less and the height is taller. Will this impact the results?
Yes, this is information needed for the reconstruction. We scale the final 3D, the image with the height. So the height can have an important impact on the final accuracy of the system. But these are, I mean, usually these are measurements that everyone knows.
Okay, so that's all. Thank you very much, Juan Carlos.